All right, we're now recording. Let me get my PowerPoint back up. There we go. And let's go from current slide. Okay. Seems like we did this one last time. I believe we finished it, didn't we? Yes. Yeah. I gave all of you $12,000 to put it in the bank. Yeah, I remember that. Okay. All right.
Great.
Yeah. Oh, maybe I forgot to do that. Okay. Now, let me go over how we're going to proceed. As soon as I can finish all the stuff that I'm talking about, I'm going to continue in Chapter 3, 3.1. We'll finish that today and move on to 3.2. I don't know if we'll get past 3.2. I kind of doubt it because it's taking so much time, but it's a relatively short section. We may actually finish 3.2 and then move into 3.3. I kind of doubt it, though. Okay? But what that means for you, okay, your test next week will be in two parts. The first part will be a Chapter 3 test, very short, fairly easy, I think. If you've been paying attention to what we've done in 3.1 and 3.2, I think you'll see it's pretty quick and easy. The second part will be the comprehensive part, similar to Chapter 1, Chapter 2, and the little bit we did in Chapter 3. I'm guessing 4 questions in Chapter 1, 4 in Chapter 2, and 2 in Chapter 3. Very short. You'll certainly, I think, be able to do it fairly easily, both tests within the 2 hours. I think you got an hour and 50 minutes. If you need more time, you certainly can take it. Y'all are aware of that, okay? So that will be your final exam. The first part from Chapter 3, it's actually a chapter test, a very easy chapter test, okay? And then the second part will be your final exam, which will be pretty simple too, because it's only going to be 10 questions or fewer, okay? All right. Any questions about the test? Okay, before I get any further, I forgot to ask my question. Have all of you done the student course evaluations? Yes? Yes? Yes, everybody? All right. Huh? What's that?
It's not many people.
Yeah, I know. That's the bad news. Okay. But hopefully they'll hear this and be encouraged that all of you have, and then they'll say, we've got to get to it. They all had. Okay. All right. So do your student course evaluation. And, of course, you know what happens next Tuesday besides the great final exam? Voting, of course, okay? And I'm going to try my very best to be here by 8 o'clock. But I've got to vote before I get here. I think I'll have plenty of time. I'm hoping for a huge voter turnout because all of you are voting, right? Okay. So, yeah, okay, yeah, you can do it after. That's fine. Yeah, I can't because I teach until 8 o'clock Tuesday night and the polls will be closed then. I'm not going to fail to vote. Okay, so please vote. All right, let's get off of that. Other things. I think that pretty much winds up what's going to happen. Let me go through the last sort of details. Today and tomorrow, regular, week. My locator card, everything else is correct. We have office hours today from 1:15 to 3:15. Have class this afternoon. Goes into the evening. We may not be here as late as 8 o'clock, but I'm guessing we'll be pretty close to it. And Fung is here. And, of course, everybody who comes in, I have to ask the same question, and you know what it is. Have you done the student course evaluation? Huh? All right. Okay. Please do it. Please do it. All right, and before you leave today, come pick up your quizzes and tests. I've already passed those out, and I don't want to go through that whole stack of papers again. All right. Okay. So office hours today is normal, 3:15 to 5:15. Okay, tomorrow I'll be on the Birmingham campus. It's normal, 7:45 to 11:45. Okay. Now, if you're planning to do something, all of you have, I think, done everything, but if you were going to need something and see me about something, please let me know if I need to take something over there, because otherwise I'll be over there without it if you're looking for something. But I think all of you have already gotten back everything except Fung, and she'll get it in a few minutes or at the end of the class. All right, next week, don't go by my locator card because finals week, everything changes. Not in the office when I'm normally there, and I'm in the office when I'm normally not there. So let me go through what my schedule will be next week. On Monday morning, 8 to 9:50, not 9:15, I will be in this classroom conducting a review session for my Math 100 students. Now, some of them may be taking their final. They can opt for that if they want to. I'll have them elsewhere. But I'll be doing a review session for my Math 100 students. So it's not a good time to come and ask questions because I'm going to be teaching then, okay? Not normal, okay. But after 9:50, or basically 10 o'clock, I should be in the office the rest of the day until 5:15. With this exception, okay? Because I'm giving a review period for my Math 100 students, they can elect to take their exam anytime they want to after that. So if some of them say, yes, I want to take the test now while it's fresh on my mind, I will be administering the test. I may be doing it in this room or any room between my office and here. The reason I do that is that way I'm closer to the office, so if I need to go get some more papers or different papers, or I may even be able to hear the phone ring. I can't from up here. I can answer the phone, that kind of stuff. So if you can't find me in my office, try every classroom between my office and here, check to see if I'm giving an exam. Because I'll just go to the nearest empty classroom and give exams from there. Okay? So that's the exception. So from 10 o'clock until 5:15, I'll either be in my office or in some classroom between here and there. Now, if you can't find me there, I may be in the restroom at lunch or, having to go to the records office or something like that. I'll be back really soon. So don't disappear. Hang in. Okay. And here is Sydney. All right. And when you come in, you get to ask the question, have you done the student course evaluations? Not yet. Okay. Please do those. Okay. All right. Now, I've already been talking about, and before you leave today, you can pick up all your quizzes and tests. I already passed them out, but we'll wait till the end to get those who came in late. All right. So I was talking about schedule for next week. Monday, I'm on a review session up here, 8 to 10 basically, 8 to 9:50, and then I'll be in the office or in any classroom between my office and here, 265 and 255, giving exams if anyone comes in for that. Tuesday, I've got your exam right here, okay? We'll be here, I hope to be here by 8 o'clock. If not, don't panic, I'll get here. I have to vote Tuesday morning. You need to vote sometime on Tuesday between 7 and 7. But I have to vote. I can't wait until after 7 in the evening because I'm here on campus until 8 o'clock. So I've got to vote before I come to class. Okay, but I hope to be here in plenty of time. All right. So I'll be in here from 8 o'clock until 9:50. Now after 9:50, I'm back in the office. So if any of you oversleep Tuesday or something like that, or you're voting and you're in line too long, come see me. I'll be in the office from 10 until 3:15. Now here's the bugaboo. I'm teaching a second mini-term class. Mini-term classes actually still have class this week, at least the first day. So I will be teaching in here from 3:15 until, I doubt if we'll go as late as 8 o'clock, but we might, okay? It probably will be sooner because all I have to do is finish the last chapter and have a last lab. And then if any of them elect to take their last test Tuesday, they can, or they can wait until Thursday when it's scheduled. Either time, or any time in between. So, 3:15 until I'm probably going to be blocked off, okay? I'll probably be through before 8 o'clock, and I'll be on campus until 8, but you'll need to just look. That won't be a good time to have questions for me and stuff like that. You can come take a test. I'll just put you in a different room. Okay. Now, Wednesday, I have no exam scheduled, so I'll either be in my office, 265, or in any room between my office, 265, and this room, 255. Check any of those. If you can't find me in my office, I'll probably be administering an exam. Could be some of those physical science students. It could be some of those Math 100 students. Okay? Or it could be late students. Okay? All right, Trey's here. All right. And for people who, came in, Have you done the student course evaluations? Have you? No, please do those. Please do those. Okay. All right. And also, I've already passed out all the quiz 1, quiz 2, test 1, quiz 2, and test 2. I passed those out earlier, so if you see me after class, I'll give you yours. Now, have all of you finished all the quizzes and tests? Okay. If you haven't, this is the time to be working on them right now. Okay. So that's Wednesday. Thursday, basically from 7:45 in the morning until 3:15, absolutely free. In my office or in any classroom in between my office and here. 3:15, technically that's when the mini-term class has their final. I don't know if any of them are going to wait that long to take it. I'm giving them the option of taking it early because a lot of them are automotive students. And some of those students are from out of state, some of them from scattered all over the state of Alabama. And that is their last final exam. And they may be just sitting up here waiting for a Thursday final when they're through with everything else. So I'm letting them take theirs early if they choose to. Now, I don't know if any of them will still be, not all of them are automotive students, not all of them are out of state or out of region, but anyone who chooses to take their exam on Thursday at 3:15, actually at 3 o'clock, I'll be giving it Thursday at 3. But that's probably not going to be too many, so if you need to come make up something, that would be a good time. I'll be in this room Thursday at 3. Now, they're not going to take more than 45 minutes probably to finish their exam. So after that, I'll be in my office or any room in between. Okay? Friday of finals week, I'll be back on the Birmingham campus, 7:45 to 11:45. And if you need something, if you're going to make up a test, finish a test or something like that, please let me know, because otherwise your test will be here, I'll be there. That'll be very difficult to do. So if you do need to see me and I need to have something for you on Friday of finals week, let me know well ahead of time so I can put it in my grade book and have it with me. Now, y'all are through after that Friday. I mean, no student, you don't have to be here anymore. We will be here another couple of days, Monday, maybe Tuesday. I don't know if Wednesday or not. Have all of you been at Lawson for a while? I take it most of you have. No, you haven't. Okay. Here's the deal. During final exam week, you cannot access Student Suite. Now, it's a really stupid reason, but it is reality. Our ancient system we have only has something like 16 portals to access the system. Okay? They may have increased it some, maybe up to 32, I don't know. But anyway, all the students on campus cannot get on at the same time. And so during finals week, everybody's checking their grades, seeing what they did. And if they're on, we can't get on to put the grades in. So the first time they did this, it was horrendous because none of the instructors could get on the system to put the grades in because students were checking and complaining they couldn't see their grades. Okay. So what they said, the only solution was, that they came up with, was to shut students down from Student Suite during finals week. And that enables us to put the grades out there. But guess what, team? Most of us, I know I do, I put the grades on Blackboard before I put them on Student Suite. Blackboard's always open. You can't not get on Blackboard, okay, most of the time.
Maintenance.
Huh?
Unless it's down for maintenance.
Unless it's down for maintenance. And that did happen in the summer. I think it was our last spring one. When we were supposed to be putting grades in, Blackboard went down. So they gave us an extra day or so to do that. That's why I don't know if it's going to be Monday at noon, Tuesday at noon, or Wednesday at noon. Someday there is when grades are due. I'm going to try to have mine in well by Monday, maybe even by Friday. But you won't be able to access Student Suite, but you will be able to do Blackboard. So check Blackboard, don't mess with it. And until the grades are due, which are Monday at noon, Tuesday at noon, Wednesday at noon, whenever that is, Student Suite will still be down for you. Not just finals week, but until grades are finally in. Okay. Any questions? All right. If not, I think we did this example last time. This is example 8. We're ready to start example 9. Okay. Y'all did this, I remember. Yeah. Okay. Example 9 is not on the PowerPoint, so let me do it on this last part of example 8. First, are there any questions on anything before we get going today? All right, here's another example of exponential functions. Radioactive decay. Important or not? Yeah, it is important. Where would radioactive decay be important? Say again? Okay, that's not radioactive most of the time. But say again? Okay, nuclear warfare, absolutely. Does anyone want to build in Hiroshima or Nagasaki right where the bomb fell? Probably not, okay? Because there's probably still some pretty bad stuff. Now, they may have cleared it out. They may have gone through, dug out the soil, dumped it in the sea. I don't know what they did. But let me ask another one. Not just nuclear warfare, but MIDI-LET. No, I'm sorry, okay? MIDI's here. Has anyone ever heard of Chernobyl?
Yes.
What was Chernobyl?
It was a Russian nuclear plant.
Yeah, actually, at that time, Soviet nuclear plant that overheated. I mean, the biggest nuclear disaster ever. Nobody lives in Chernobyl. Nobody lives close to Chernobyl because there's still radioactive decay in the area. In fact, they've got a thing called the elephant's foot or something like that, a big mound of really toxic radioactive waste that's there that they do not know what to do with. It's incredible. Now, I happen to know this for a fact, okay? Kids that were born in that area, as much as a decade and maybe close to 2 decades later, if they were too close to the area, were still being born with birth defects because of that radioactive decay. The reason I know that, a kid took my Math 100 and 112 class, sat in that corner seat right back there. He was from Ukraine. His parents had abandoned him because he was deformed when he was born, and he was adopted. He was living in a orphanage, not very good orphanage, and a family from the U.S. adopted him and brought him to the U.S. He was missing an arm. It never had been there. I think they said he had a finger or two sticking out of his shoulder. I mean, it was that bad. He had, I think, a hair lip or something. They had done the operation to repair that. He had some developmental issues and other things. He never gained weight well, but he was one great kid. And he took my Math 100 and 112 class and is working on being a physical therapist assistant. I think he thought he had the cognitive ability to do a physical therapy, but he wanted to be physical therapy assistant so he could help other people who had physical handicaps. He was born at least a decade after Chernobyl happened, but it was close enough in the area, still was affecting people. It's sad. Yeah, radioactive decay is an important issue. Now, not just that, on the good side. I had half a kidney removed because it wasn't any malignancy, but I had a thing called an angiomyolipoma, which is blood. Angi is blood, myo is muscle, and lipoma, unfortunately, is fatty stuff. And it was just a benign tumor on the kidney, and it was growing. It seemed to be growing. So they had to take it out, but they had to take half the kidney. But they wanted to test to see if the kidney functions were still working well. They injected a magnesium radioisotope into my blood, and they were able to see on the screen how well the half kidney was doing compared to the full kidney. So, very positive. But of course, that radioactive decay dissipated within a day, and I just had to drink plenty of fluids and just get it out of the system. So, very positive things, radioactive decay as well. not just negative things. Also, I had a heart not fibrillation, flutter. And the doctor wanted to make sure everything was fine, and he injected a dye. I was on the treadmill and injected a dye and then measured, and he said, it looked like a textbook, good heart. So everything came out well, but they were able to do that with no invasive surgery at all, just injecting a radioisotope. So very positive things, some negative things as well. So let's do example 9. In 1986, oh, look at this. The nuclear reactor accident occurred in Chernobyl. And by the way, it's not just Chernobyl. Anyone ever heard of 3 Mile Island? That's somewhere, I think, Pennsylvania, New York, somewhere like that. Here in the US of A, we came that close, or maybe that close, to having Chernobyl there. Fortunately, we had the systems in place. They could shut down things really quickly, but no one lives on 3 Mile Island anymore, I don't think. They didn't have a major meltdown, but it came close. Anyone ever hear of Fukushima? What was that?
Oh, that was recent.
Oh, very recent.
After the tidal wave.
Yes, exactly. There was an earthquake, a naturally occurring earthquake off the coast of Japan, and Japan has no fossil fuels to speak of, so they were using, and they're a very industrialized country, so they were using nuclear to provide the vast majority of their electricity. They unfortunately had a nuclear power plant right near the beach where the tidal wave came in, flushed the plant. Even though it was one of the safest plants in the world, the tidal wave was enough to just completely wipe it out, shut the reactor down. They didn't have time to get it shut down easily. They had probably almost as major of a problem as Chernobyl did. But theirs was very, very well contained, with the exception of all the radioactivity that washed into the ocean. We won't know for a long time what that was. Now,
That was 5 years ago?
that was what?
5 years ago?
Something like that. Something like 5 years ago. And Japan has really backed off their nuclear power. They're importing oil again to provide the power. So they're paying a big price because they're scared now. Okay, and I don't blame them. But some really good story came out of this, or at least it sounds good, warms the cockles of my heart, but I feel sorry for the guys. Because the plant was inundated and they couldn't get to it, no one could get to it without risk of their lives, but they still needed to shut some things down. And this speaks so well of the nature and character of generally the Japanese people. Older men who had retired from that plant said, don't send in your current employees to clean up the mess. They're in the prime of their lives. It's going to affect them. Send us in. We don't have that much life left. There's no reason to mess up another generation. And those guys volunteered to go in and do the really nasty, dangerous, hazardous, basically fatal work that needed to be done. They did it. And as far as I know, they did it pretty well. Probably. I don't know. I haven't followed up or heard that, but my guess, well, they were old men, so they probably were close to their life expectancy anyway. But they said, don't send in young guys with families and stuff like that. Send us. There's some heroes out there still, folks. Okay, election not aside. No, never mind, I won't go there. Okay, so in 1986, a nuclear reactor accident occurred in Chernobyl, in what was then the Soviet Union, now part of Ukraine. Okay, the explosion spread highly toxic radioactive chemicals such as plutonium, and if you know chemistry, that's 239 Pu. Pu stands for plutonium. 239 is the atomic mass of plutonium. Over hundreds of square miles. Hundreds of square miles. And the government evacuated the city and the surrounding area to see why the city is now uninhabited, okay? Consider the model, and here is the model. And you model this with exponentials. P is equal to 10 times 1/2 raised to the T over 24,100. Okay. And Chelsea's here. All right. Now, I ask everybody coming in, have you done the student course evaluations? All right, good deal. I passed out to everybody else who was here at the beginning their quizzes and tests, so before you leave today, pick up yours. And you can hear everything else on the YouTube. So listen to that about what's going to be covered on the final, and it's going to be actually 2 parts. Chapter 3 test, then the final exam. Okay? Comprehensive. So, but they're both very short tests. You'll easily be able to do those, I think, in the hour and 50 minutes. But even if you can't, you got all week. Okay? We will have the test Tuesday morning at 8. The tests, 2 tests. Okay? And if I'm not here right at 8, it's because I'm voting. Because I can't vote afterwards because I'm here till 8 o'clock at night and polls are closed. So I'm going to be voting as soon as the polls open in my neighborhood, and then I'm going to be rushing to campus after that. Okay, so here we have. This represents the amount of plutonium, P, that's the amount, that remains from an initial amount of 10 pounds. 10 pounds of plutonium. Doesn't sound like much, does it? But it can be very, 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 very deadly. Okay? 10 pounds after T years. This isn't minutes or seconds or hours, weeks or months. That's years. Okay? Now, it says to sketch the graph of that function interval from T equals 0 to T equal 100,000. Okay? Where T equals 0 represents 1986. How much of the 10 pounds will remain in year 2020? We're not even there yet. Okay? So that's what we're going to do. All right. So let's do, you want to sketch it first or you want to calculate first? I don't care. Let's calculate. So the question is, how much will remain in year 2020? Well, if T equals 0 represents 1986, what will 2020 be besides a television show? "24 years later," almost a quarter of a century later. So let's put in T equal 24. So is it 40? Wait, I'm trusting y'all. I shouldn't do that. 34. You're right. 34 years later. Okay. Okay. Knock it off. I don't want to hear about it. Okay. 34 years later. So T equal 34 years. It's recent I said that. And one of my classes, one of my students one time, this was a year or so ago, I had mentioned, my leukemia. They said, well, how long have you had this? I said, well, it was discovered in 91. And someone said, I wasn't born then. I was like, shut up. Okay, I don't want to hear about it. I don't want to think that. Okay, never mind. Okay, so never mind. So 10 pounds in 1986 times 1/2 to the 34 divided by 24,100. Okay? Now, I hope, and remember I said, please bring your calculators to the test. You're going to need them, okay? I can't do this in my head, okay? I doubt if you can, okay? So please bring your calculators and know how to use them. Does anyone know how to do this on a calculator? Okay, it depends on your type of calculator, but on most of the nicer ones, if you got a cheapie, a freebie, you probably can't do this, okay? Because it doesn't have the E function, okay? So you do 10. Now look for a key that is y to the x is one way. Another way would be the caret key. Y'all know what I mean there? It looks like a housetop teepee. Okay, find a key like that. If you have a y to the x, you do 10 times, you press in the 1/2 or 0.5, then the y to the x, and then you open parentheses and do 34 divided by 24/100, close parentheses, hit equal, and you got it. If you have the caret key, it's 10 times 0.5 or 1/2, you can do either one. I do 0.5. Caret, and then do open parentheses 34 divided by 24,100, close parentheses, hit equal. Has anyone got an answer yet?
9.99.
Say again? 9.99 pounds left after 34 years, and we're not even there yet. That's 3 years away, folks, okay? And you still got 9.99 pounds. It doesn't go away fast. How about let's doing 100,000 years? I don't think I'll be around then, but let's try that one. P is equal to 10, 1/2 to the 100,000 divided by 24,100. You think minuscule amount? What do you get? Anybody? Say again? I can't hear. Say again?
I don't even have a whole number. I don't think
She doesn't think her answer is right.
Well, tell me what it is.
0.56.
That's exactly right. 0.564 pounds. You still have half a pound of it left 100,000 years later. That's scary. Half a pound of plutonium is not nice to mess with either, okay? Still emitting radiation. Now, I want to tell you something. The book hasn't gone into it, but you know what this 24,100 is?
It's not like
As a name. The half-life. That's the half-life of that plutonium. That means after 24,100 years, that 10 pounds is down to 5 pounds. Okay? After another 24,100 years, it's down to 2.5 pounds. And that turns out, you see what's happening? It never goes away. Ever. So yeah, no one lives in Chernobyl. No one will live in Chernobyl pretty much for the rest of the time. Okay? 3 Mile Island, I doubt if it was quite that bad, but I wouldn't be surprised if no one's going to live there for a very long time. Oh, those were accidents, right? They don't happen very frequently. But guess what? Now, this is sort of sad. Whenever you have nuclear reactors, which we have in certain power plants, we have at least 1 or 2 in Alabama. I know there's some over in Georgia. There's some, all over. France is largely nuclear. All over the place, there's nuclear power plants. We've had nuclear submarines most of my lifetime. We have nuclear aircraft carriers. We have nuclear other ships, in the Navy. There's nuclear power, lots of places. Okay? When you use up most of the useful radiation from plutonium and other things like this, you still have some radioactive waste left. What do we do with the radioactive waste? Okay. That radioactive waste can last maybe not 24,000 years, but an awful long time. And right now, what they're doing with it, as far as I know, they're still doing this. They're hauling it from all these sources, all the nuclear power plants, or nuclear submarines and aircraft carriers, all that. They haul it and bury it in a mountain, in some caves underneath a mountain in Utah, I believe it is. I believe it's Green Mountain or White Mountain or something like that.
Blue Mountain.
Some people, Green Mountain,
I said blue.
Blue Mountain. Oh, you're right. Okay. It may be Red Mountain after a while. No, I'm just kidding. Okay. Okay. But you know what? And this was shortly after we moved to Birmingham in 1986. So it may have been 87, 88, somewhere around in there. There was a proposal to haul some of that nuclear waste from the Northeast, where they had a lot of nuclear power plants, to Greene County, Alabama, and put it in the landfill.
No.
And yes, and actually it was on the train on its way, and someone blocked it before it got to the state of Alabama.
Oh, it's
And
the
sent
Alabama
it back.
wrong.
Huh?
That was the Alabama wrong.
That, yeah, totally wrong. Because guess what? I mean, you don't want to do that to Greene County, but what's underneath Greene County? An aquifer. And if some of that wood leaks out in the next 20,000 years or so, it gets into the water, and that gets down into the Gulf of Mexico. Who knows how much damage can happen? And guess what they do with it? I mean, they need it to last, 10, 20,000 years, these containers. How many containers do we have that we guarantee can't leak in 10,000 years? We don't know what built containers for 10,000 years. We don't know. Even in Green Mountain, Utah, where hardly anyone lives, but still, there's water underneath there. Ew. Ew.
Send it to China.
What's that? Okay. It is scary, folks. Sorry. Don't mean to be a Debbie Downer here. Okay. So, you actually want to see the graph? The graph is exponential decay, but it's a fairly
Antarctica, nobody lives there.
slow slope. It's decaying, but it never goes away. After 100,000 years, there's still more than half the time left.
How much money do you think it would take to send it to another continent?
Another continent? What other continent do you think might want it?
Antarctica. Nobody lives there.
Okay, well, let's see. If we're worried about the ice melting in Antarctica now, you know, I don't know. There's no safe place.
Also penguins.
Okay, I was just wondering that too. Maybe we should send it into space,
I think that we
and we just hope that rocket doesn't explode like, you know, remember the Challenger?
You can send it to the moon.
That's true.
Yes, okay. SpaceX may be good, but they're not 100%. What if it explodes in our atmosphere?
Just send it to the White House.
Bye bye, baby. Okay. So I don't know. It's scary, people. Okay. Enough of that. All right. Let's move on to any questions on that? Know how to do your calculations there.
It's like calculator stuff, really. As long as you know how to plug it into the calculator, that's all you need to know.
What's that again?
This chapter is just basically, as long as you know how to plug it into a calculator, then you'll pretty much get the answer every time.
Well, yeah, and what it's talking about, and you think this test bank is not going to have a graph on it or two?
Oh, no.
Of course it will. Okay. Yeah. But let's do the second. Oh yeah. Wait. Before we go, I'm sorry, I'm running off at the mouth too much today. 3.1 vocabulary. Polynomial and rational functions are examples of blank functions. Polynomial and rational functions. It's on the very first page of this section. Very first sentence in this section. Algebraic functions. See that very first sentence? Okay. Number 2, exponential and logarithmic functions are examples of non-algebraic functions, also called blank functions. Second? No, those are algebraic. Polynomial is quadratic. Quadratic or polynomial. They're called transcendental functions. Okay, yeah. Transcendental functions in that first paragraph also. Number 3, the blank property can be used to solve simple exponential equations. There's something else you can do, solving exponential equations. We did that last time, remember? That's called the one-to-one principle. Okay, where was that? Yeah, I can't see it, but one-to-one property. Yeah, there it is on example 4. Number 4, the exponential function f of x equal each of the x is called the blank blank function. Natural base function or natural exponential function is probably better. Okay, natural exponential function, and the base e is called the natural base. Blank base is natural base. To find the amount in an account after 2 years with the principal P and an annual percentage rate R in decimal form, compounded n times per year, use the formula, page 203, one at the top of the page there. A is equal to P times 1 plus R over N times NT. Okay, raised to the NT power, not times, raised to the NT power. To find the amount A in an account after T years with principal P and the annual interest rate of R in decimal form, compounded continuously, what formula is that? That's at the bottom of page 203, top of page 204, several places there. That's the one I remember as PERT, okay? A is equal to P, that's the principal, E, that's the natural base, to the RT. Much easier formula, okay? And gives you a little more interest too, okay? Homework exercises here, any of the odds 7 through 11. 7's in calcview.com, all the odds are calccheck.com. I would do all of 13 through 16, but only 13 and 15 answers are in the back and on calcview.com. I mean calccheck.com. Any of the odds 17 to 23, all those are on calccheck, but the 21's on calcview. Do either 25 or 27 or both. 25's on calcview, both of them are on calccheck. Either 29 or 31, calcview has 29, both of them are on calccheck. Either 33 or 35, 35's on calcview, both of them are on calccheck. 37 or 39, 37's on calcview, both of them on calccheck. Either 41 or 43, either 45 or 47, none of those are on calcview, but they're all on calccheck. Either 49 or 51, 49's on calcview, 51, or both of them are on calccheck. Do either 53 or 55. So you see there's lots of other problems here, interest problems. Jalen, you were asking? Yeah, okay. So there's lots of other things besides just using calculator. Okay. And then any of the odds 57 through 65. Okay. And unfortunately, none of those are on CalcView, but all the odds are on CalcChat. Okay, there's a true false you might want to look at. I don't know if that's on CalcChat or not. You can check. Think about there's 69 or 71. You don't have to do those, but you can do them if you'd like. Graphical representation, 75. That might be fun to look at, or 77, comparing graphs. Another think about it on 79. You don't have to do those, only if you want to. So let's move on to 3.2. Not got a lot of time here, but let's do what we can. What were some characteristics of exponential functions? Is it exponential growth or exponential decay? What's true about both of them? Yes, one is constantly increasing, one is constantly decreasing. That makes both of them one-to-one functions, okay? One-to-one functions. And what's true about every one-to-one function? This is from an earlier chapter, chapter 1, I think. They have inverses. Every one-to-one function has an inverse. And guess what the inverse of an exponential function is? Logarithmic functions, okay? So we'll recognize and evaluate logarithmic functions with base A. Guess what? We'll graph some logarithmic functions. We'll recognize and graph, evaluate and graph natural logarithmic functions. That's base Not A, but natural base? E, okay. You saw a mouse? No, never mind. Okay, you will use logarithmic functions to model and solve some real-life problems. Finish? Good deal. Thank you. Okay, so let's look at logarithmic functions. Every function in the form of f of x equal a to the x passes the horizontal line test, which means it's a one-to-one function, okay? Therefore, it must have an inverse. That inverse is called the logarithmic function of base a. Now, here's the thing to remember, folks. In an exponential function, the thing underneath the exponent, that's the base. In a logarithmic function, the base is right there. It follows the log, okay? So the definition of a logarithmic function of base a for any x's greater than 0, guess what? That gives you the domain. What's the domain of any log function? Only positive x's. Not 0, not negative. You can never take the log of 0. You can never take the log of a negative number. Ever. Okay? Now, your a also has to be positive. The base has to be positive. The variable has to be positive, also the base does. But we also don't allow the base to be 1. Because what if the base was 1? That's always 1. Okay? That's a constant function. 1. 1 to the 17th power is still 1. You know, 1 to the negative third power is still 1. You know, so that's not very interesting. So we have to have a's being positive but not equal to 1. They can be between 0 and 1. They can't be 0, can't be 1. Be in between, or they can be greater than 1. So here's how we write it. Y is equal to log base a of x. Okay? If that's your log equation, that's a logarithmic equation, that's true if and only if the corresponding exponential equation is true. And here's how you do that. It's the same for inverses, if you remember. What do we do with inverses? Switching the input and output. Okay? So if your input here is x, and your output is y with base a, log base a, this is true if and only if what was the input here becomes your output, the base stays the same, base here is a, base here is a, now the input here, y, was what was the output for the log, and vice versa. You flip the input and output, okay? So that means that these are equivalent equations. The function f of x is equal to log base a of x, okay? It's called the logarithmic function of base a. Now that a can be any number greater than 0, just as long as it's not equal to 1. It could be a 1/2, a 0.3, it can be 6 million, you know, any base whatsoever. Except 1, 0, or negative. You can't have a negative. Okay. So these two equations are equivalent equations. This is expressed in logarithm, that's expressed in exponentials. Okay? And notice the key here, the bases are always the same, and your input and output are reversed. Okay? Now, y'all will need to listen to those who just came back. Before you leave today, pick up your other quizzes and tests, because I passed those out early. And also, you'll need to listen to YouTube. It'll be out there sometime this afternoon, and hear everything I said about how things are going to work. Your final exam will be in 2 parts. One part, chapter 3, what we're doing today and yesterday, last time. That'll be a very short test, 10 questions or less. And then the comprehensive part will be 10 questions, probably 4 from chapter 1, 4 from chapter 2, and 2 from chapter 3. Okay? So, these are equivalent equations. The first equation is logarithmic form, second is exponential form. So here's an equation. 2 is equal to log base 3 of 9. I want you to give me the equivalent equation for that. 9 equals 3 to the 2. Perfect. 9 is equal to 3 to the 2. Give me the equivalent equation for that.
You got 3 equals Well, 125 right beside.
Okay, so that you almost had it. 3 equals log base 5 of 125. Exactly. There it is. They put the 3 on the other side, but it's perfectly fine. Do you see how to rewrite an equivalent equation? Okay? Good deal. I've lost my chair. Okay. I was hard to sit down. That would have been fine. Okay. When evaluating logarithms, remember that a logarithm is an exponent. Okay? A logarithm is an exponent. Whatever the log is of, that's the exponent of something else. That means log base A of x is the exponent which must be raised to obtain the value x. Okay? So here's another one. Log base 2 of 3. Log base 2 of 8 is equal to 3. How would you write that otherwise?
The other way?
Yes.
8 equals 2, right?
8 equals 2 to the
Third.
third. Absolutely. That is, 8 is, this thing here is 2 raised to the third power. Because 2 raised to the third power is saying the same thing. Very good. All right, let's do some. Evaluate each logarithm at the indicated value of x. Okay? First we'll say, whoa, let me get my pen. Okay? Let's do this one right here when x is equal to 32. So we'll say log base 2 of 32 is equal to what? Say again? 5. Why is that true? Because 2 to the 5th is equal to 32. Perfect. You see how he did that? Put your base to be the base here. This is what you're looking for. 2 to the what power is 32? To the 5th power. Okay, let's do this one. Log base 3 of x of 1. Let's do 1. What is that equal to? That means 3 to the blank is equal to 1. 3 to the 0 is equal to 1. So there's what it is. You see how this works? Question? Okay, let's do the next one. Log base 4 of 2 is equal to blank. Okay, let's try it. What's your base? 4 to the blank is equal to 2. 1/2. You're absolutely right. The square root of 4 is 2. Okay? Got it? All right. How about the D one here? The log base 10 of 1 over 100, my numbers keep disappearing, is equal to what? Rewrite that as 10 to the something is equal to 1 over 100. -2. Perfect. That's -2. So therefore, even -2, that works here. That's what goes there. You see how that works? All right. Let me erase my scratch, and let's see. Now theirs, I'm not sure it's going to be any easier to see, but it's exactly what Tef said before. Alpha 32 is log base 2 of 32. That's what we mean there. See, I don't like the way they do it because, oh, okay. 5 is the answer, okay? It's hard to find the answer in that, but 5 is the number. The answer is 5, okay? So therefore, that is 5. Okay, got it. I just happened to click my button as many times. Because 2 to the blank power is equal to 32, 2 to the 5th power, so that blank has to be 5. Okay? f of 1 is equal to log base 3 of 1. Well, you write base 3 of blank is equal to 1. Only way you can get there is 0. Okay? F of 2 is log base 4 of 2. Okay? That problem. So you rewrite it. 4 to the blank is equal to 2. Well, that has to be 4 to the 1/2, because square root of 4 is 2. Y'all do realize with an exponent, a fractional exponent, the numerator is a power, the denominator is the index of a radical. You did know that, right? If not, that's the key. That is the key. And when you don't see an index for radicals, you understand it to be 2. So that's 1/2. Okay? And then f of 1 over 100 of log is equal to log base 10 of 1 over 100. So you write 10 to the blank is equal to 1 over 100. Well, 10 to the blank would be 10, 1 over 100 is 1 over 10 squared, so that would be 10 to the minus 2. So your answer is minus 2. All right. Unfortunately, we are out of time. Okay? So your first part of your test will be a little bit on chapter 3. Okay? And then the second part will be your comprehensive. 4 questions on 1, 4 on 2, and 2 on 3. Yes? Question? Okay. Anyone who came in late, didn't get your quizzes and tests, stop here and I'll give them to you.